Okay, today we are going to learn about one sample test for the proportion. So one sample test for the proportion are using this formula to calculate the test statistic. Okay. Catsoft sampled 44 customers and asked them to rate the overall quality of a software package. Sample data revealed that 35 respondents, a proportion of 35 over 44, that gave us 0.795, thought the software was very good or excellent. In the past, this proportion has averaged about 75%. Is there sufficient evidence to conclude that this satisfaction measure has significantly exceeded 75% using a significance level of 0.05? So from the question, they give us the H0 and also the H1. The H0 will be 0.75. Okay, so you are going to find all the numbers in this formula. So the first one, we will find the N. The N is the total number of customers, that is 44. And then this is the sample proportion, which also been given to us in the question, 0.795. And then the H0 is 0.75. Okay, to find the test statistic, to make it easy for you, you have to calculate the numerator first and then the denominator. For the numerator, the sample proportion divided by the H0. So, sample proportion minus by the H0, 0.045. And then the denominator, we are using the Excel function square root, SQRT to find the square root, the H0, and then open bracket 1 minus by the H0, close the bracket, divided by N, 44. Okay, that is 0.065. And then calculate the test statistic. Put in the formula, 0.69. So because this is an upper tail test, we reject the H0 if the value of the test statistic larger than the critical value. So that is why we need to find the critical value. To find the critical value, we use the norm as .inv, the probability 0.95. So why we are using 0.95? It is because the significance level is 0.05, which is give you the confident level of 0.95. So the test statistic does not exceed the critical value, so we cannot reject the H0. And then even the sample proportion exceed the 0.75, this one, we cannot conclude statistically the customer satisfaction has improved. So that is why we need to find the p-value. So the p-value can be computing the area to the right of the test statistic in the standard normal distribution. So we are going to use the formula of 1 minus by the norm as distribution, our z, and then true. Close the bracket, and then you get 0.24. So 0.24, our p-value is greater than the significance level 0.05, and that leads us to the same conclusion just now of not rejecting the H0. So